So this is going to be note 6.5, a little bit of review from previous in the chapter. We had talked about when it talks about counts, like how many out of a certain sample. Okay, we had our mean and our standard deviation. And if we talked about our proportion, a certain percentage, okay, counts was how many, a proportion would be the percentage. Okay, we have those different means and standard deviations. With both of those, we said the shape was approximately normal if n times p and n times 1 minus p are greater than 10. And then to find the different probabilities, we use normal distribution. One does most to find that. Okay, so today we're going to talk about what about if we're finding the mean? Okay, finding the mean. So here are two things we're going to learn today. Find the mean and the standard deviation of a sampling distribution of a sample mean. Okay, so we're finding the mean of all of our samples and interpret the standard deviation. Then use a normal distribution to calculate the probabilities when it's from a normal population. Okay, so basically, if I find, let's say I take, thinking about that, we have this population, right? And I take a sample of 5 different numbers, right? And I find we have those 5 numbers and I find the mean. Take another sample of 5 numbers and find its mean. Another sample of 5 numbers, find its mean. That's what we're talking about today, okay? We had kind of talked about this earlier. The center of this one is going to be the center of our sampling distribution, okay? So I know that each of these is an x-bar, right? Each of these is a sample of 5, the mean of the sample of 5. So if I take all these x-bars and put all these x-bars together, all possible x-bars, the center of this is going to equal the center of this. Okay, so that's where we come up with our mean. We know the mean of the sampling distribution is equal, mean of all my x-bars, right, is going to equal the true mean. Okay, now to find the standard deviation, of this, we're going to use the formula. The standard deviation of our whole population divided by the square root of n. That's how we find the mean and the standard deviation. Okay, so let's look at an example. Number of movies. This has probably changed since this book because of the pandemic, but anyway. The number of movies viewed in the last year by students at a large high school has a mean of, okay, so my population has a mean of 19.3 and a standard deviation of 15.8. Okay, suppose we take a simple random sample of size 100 students. We take 100 students, find the mean, take another 100 students, find the mean, etc. Okay, the mean and the standard deviation of the sampling distribution. So, what is the mean and the sampling distribution of my sampling distribution? What's the mean and standard deviation? Okay, so I know the mean of this one is going to equal the mean of this one. So I know this is going to have a mean of 19.3. And my standard deviation is going to be the standard deviation of my population divided by the square root of n. So it's going to be 15.8 divided by the square root of, we're taking a sample of 100. Okay, so the square root of 100 is 10. That divided by 10 would be 1.58. So notice this will have the same center, but it'll be a lot tighter, right? Because we're taking a sample. If I take a sample of 100 kids and find their average, it's not going to be nearly as spread out as if I just take individual people. Okay, so there's how I find the mean and standard deviation. Now, let's talk about shape. Okay, we had said that if n times p and n times 1 minus p is greater than 10, it's approximately normal. Okay, and then we can have our approximately normal shape, right? Now, here we're going to talk about two different things, one today and one tomorrow. Today, we're going to say if our population is approximately normal, then our sampling distribution is also going to be. Okay? So as long as it says our population, what we start with is approximately normal, then our sampling distribution is also going to be approximately normal. Tomorrow, we're going to talk about what if the population is not approximately normal? What if it's skewed or something like that? How can we then tell if it's approximately normal? That'll be tomorrow's. Okay. And then once again, for the probabilities, we're going to use the normal distribution. Okay. So let's look at another example here. So at the P Nutty Peanut Company, dry roasted shelled peanuts are placed in jars labeled 16 ounces by a machine. The distribution of weights is approximately normal, so it tells us that our population is approximately normal with a mean of 16.1 and a standard deviation of 0.15. We're going to find the probability that a mean weight of 10 randomly selected jars is less than the advertised weight of 16. Okay? So I'm taking a sample of 10 jars. So in those 10 jars, I know my mean is still going to be 16.1. Okay, but I know my standard deviation is going to be the 0.15 divided by 0.15 divided by the square root of 10, because the sampling distribution will make a smaller one, right? Okay, so if I take 0.15 and divide it by the square root of 10, I get a standard deviation of 0.047. Okay, and since my population is approximately normal, I know my sampling distribution is approximately normal. Mean of 16.1, standard deviation of 0.047. Okay, now what's the probability that when I select 10 jars, the mean of those is going to be less than the 16 ounces? So we want to know the probability that that's going to be less than 16 ounces. Okay, it's actually probably more like down there or whatever, right? Because I have a small standard deviation. Okay, so you find that, go to Desmos and okay, normal distribution like we've done other days. Our mean of 16.1, comma, standard deviation of 0.47. Check the cumulative, and we want from negative infinity up to 16. Okay? And when you put that in there, you get probability that they are less than 16 is, what did it come up to be? 0.0167. Okay, so it's actually like down here, what we just found. Okay, so all 10 combined, much less probable. Okay, so if I have that 10. Okay, so one more example for us today. Are college women taller? Okay, the heights of young women follow a normal distribution. Okay, so I know my population. Let's see if I can get it. Okay, the population is normally distributed with a mean of 64.5 and a standard deviation of 2.5 inches. Okay, now if I take a sampling distribution of size 15, so I take 15, find the mean, take 15, find the mean, take 15, find the mean, right? I know my center, I know that the shape is going to be approximately normal because this was approximately normal. I know my center is still going to be at 64.5, but my standard deviation is going to be the standard deviation of the population divided by the square root of 15. Okay, so 2.5 divided by the square root of 15 gives me 0.645 as my standard deviation. Okay, so interpret that standard deviation. We didn't really talk about that. Remember, standard deviation is how far from the mean, right? So on average, the heights of women, if I take a sample of 15, will be that far away from the mean. Okay. Find the probabilities that the mean of 15 round women exceeds 66.5. So there's 64, 66.5 exceeds it would be this. Okay. So you're going to go to Desmos and do that. I guess I can do that. I'll go to Desmos and show that here. Okay, so we go functions, distribution, so it's approximately normal, right? Our mean was 64.5 inches. 0.5. And our standard deviation we said was 0.645. Okay, so there's my curve. And I want to know the probability they exceed 66.5. Oops. Pick 66.5 and above. So we can see here that 66.5 and above is a very small probability, not even 0.1%. Okay, not even quite 0.1%. So not very likely to get 15 women and find their mean and have it be 66.5. Okay, so we know that 66.5 and above was not there. It was like really, really small. It almost would not happen, right? Suppose we went over to JMU or another place and a local college, and it's a mean of 66.5. Okay, so that we do select 15 women over at JMU, and their height is 66.5 inches. They're averaged together. Based on our answer, what would we conclude about the women at JMU? Okay. So if it's not likely to happen, we might conclude that the mean really isn't 64.5, but it actually is higher. So maybe the women at JMU are taller than the average U.S. woman, young woman. Okay, so we learned couple things today. Just to summarize it, we found the mean and the standard deviation. Oh, move that down. Mean and standard deviation. We thought about the shape, if the population is approximately normal or sampling distribution is as well. And then we found the probabilities as well. Okay.